It is 6 p.m. and the meeting can now begin. Good evening, everyone. I am Rachel Massey with Holloway Environmental and Communications, and I would like to welcome you to tonight's meeting. Tonight, the project team will be presenting information on the Lower Clear Creek and Dickinson Bayou watershed study with a focus on Phase 3 of the study in Dickinson Bayou. As you can see on the first slide on the how to participate in tonight's meeting, you can provide questions or comments throughout the meeting. As deemed appropriate by the project team, your question or comment may be addressed during the presentation, or your comment will be put into a queue to be answered in the order received at the end of this presentation. Using the Q&A chat feature at the bottom right-hand corner of your screen, you may also email the project team at lccdb@leaguecity.com. And as always, visit the project website at www.leaguecity.com/LCCDB for more information about the study and a copy of tonight's presentation and a video recording as it's available. Tonight's meeting will be a live presentation hosted by the project team. We look forward to all input regarding the study and this presentation tonight. And with that, I will now turn it over to our moderator, Chuck Wolf.
Chuck, you're on mute. Or we can't hear you. It's try testing your audio again.
Okay, can you hear me now?
Yep. Yes, sir.
Okay, sorry. All right, so thank you all for attending this evening. The focus of tonight's meeting is the Dickinson Bayou watershed. Those of you who have participated in other meetings will know we're talking about Lower Clear Creek as well as Dickinson Bayou. So the information you're going to see tonight is going to be the output of our Phase 3 efforts in the watershed study as it relates to Dickinson Bayou. Brian, next slide. So our agenda for this evening is we'll go through some quick introductions, and then we'll have a discussion about the project purpose and backgrounds to bring everybody up to date with where we are. And then we've got a 4-part technical presentation, which will hit on hydraulic modeling, damage assessments, individual mitigation concepts, the combination mitigation solutions that have been come up with, and Brian Gettinger will be taking us through that, our project manager. We're also going to focus on our combination mitigation conclusions. So we've looked at different ways to solve the flooding issues within the main stem of Dickinson Bayou. We have done some work on funding partnership opportunities. We'll bring that information forward to you. Some information about a path forward, and then we should have some time for follow-up questions and comments that we receive through the Q&A. So with that, I would like to turn it over to John Baumgartner, the city manager for League City, for a little bit of an introduction. John?
John, you're on mute.
Do we have John yet?
Yeah, bear with us 1 minute. We just have to bump John up to a panelist. There we go.
Okay. So John, can we hear you now?
How's that?
Yes, we got you. Okay.
You know, it's always a technological challenge for us generationally challenged folks. So I made it. I just wanted to welcome everybody to this next meeting on the Dickinson Bayou watershed study. You know, obviously thank all our partners, Army Corps of Engineers, Harris County, Galveston County, Brazoria County, Dickinson, Friendswood, Pearland, Webster, Nassau Bay, League City, and just all the cities up and down the watershed. It's important that we have everybody participating, so as we look at the different solutions and challenges that we get through that. I obviously listed everybody on both Clear Creek as well as Dickinson Bayou. Most importantly, we've got the general public and all the citizens that make this happen, and then the support from all the city counties and commissioners' courts and colonels at the Corps, trying to put a program together that helps us harden our communities and make them more resilient to flooding, and then most importantly, our technical folks, Freese Nichols, RPS, and Holloway. And so I hope everybody finds it valuable. I've been saying for a while, the easy part's the study part. I know we've been working on it for most of the last 16 months, and we've been talking about it for most of the last 3 years. But the heavy lifting is what's the right solution? How do we afford it? How do we pay for it? And we're not going to solve all those problems, but first we come up with a technical solution. And so again, appreciate what everybody's done to get us here and look forward to the presentation tonight. Thank you, Chuck.
Thank you, John. So some key team members that we have that have been a part of this process throughout. Not everybody's going to talk tonight, but we have folks available if there's questions. So you just heard from John, the city manager for League City. Anthony Toledo is our project manager for League City. My name is Chuck Wolf. I'm the project director for this work. Brian Gettinger, you're going to hear quite a bit from tonight as our project manager. Our technical and modeling team that really led a lot of the efforts that underpin the recommendations was led by Jim Keith with Boris Minot. And then Holloway, you already heard from Rachel, and then Greg Sepchek is also helping us with our meeting facilitation. We've been doing a lot of coordination of this project with other teams that are also working with Galveston County as well as with the City of League City. So Natalie Cheney and Louis Perdita from RPS have been plugged into this process throughout, as well as Georgina Aurelio and John Grounds from LJA. So without everybody's contributions, we wouldn't be able to have gotten to the point where we are. About a little over a year ago, we met in person for the first one of these public meetings. Now we have a chance to have the third and the final public meeting for this phase of the work. So with that, I will turn it over to Brian Gettinger to take us through the presentation. Brian?
Yep, thanks, Chuck. Appreciate you setting the stage for us today. You guys hear me okay?
We can hear you fine.
Yes.
All right, very good. Make sure my audio sounded a little funny. I want to make sure everyone can hear me. So Chuck mentioned the two different studies. We'll talk a little bit more about how they tie in. The Master Drainage Plan for the City of League City is focused on municipal drainage. Our study tonight that we're talking about is focused on the riverine effects on Dickinson Bayou particularly. Obviously, everything that happens on Dickinson Bayou is going to affect local drainage and all the channels and conduits that go into the bayou as the bayou level goes up. It affects those things. So we're coordinating with them, Master Drainage Plan, and also very closely coordinating with the Galveston County Mainland Flood Study conducted by RPS. So a lot of things have happened since Harvey around how can we plan better for flooding, and we've been working together with those other parties to make sure that we are all pulling the rope in the same direction. All right, so we're going to start, before we dive into the results, talk a little bit about how we got here. Focus on the project purpose and the journey that we've been on through the project. We've been working on this for over a year. Have some exciting results today, but want to make sure we set the table for anyone, particularly who wasn't able to attend the previous public meetings. So, firstly, our project purpose is to develop a comprehensive flood mitigation plan for both the Lower Clear Creek and Dickinson Bayou watersheds. Tonight's presentation is focused on Dickinson Bayou. Tomorrow night, same time, we'll talk about Clear Creek. Part of that effort is including the identification of vulnerabilities in the watersheds and the development and refinement of concepts to reduce flooding. So we are focused on reducing flooding risk. That is going to help people that back up to the bayou and creek. It's going to help people that live away from it, that have a storm sewer tied into it. It's going to make the communities more resilient. So our focus is on rainfall. We'll talk a little bit about how that's different than surge, but rainfall events, particularly large ones like Allison and Harvey, and how we can mitigate flooding to make our communities more resilient. I think most folks are probably calling in from this project area, and you guys are pretty familiar with this map if so, but tonight's presentation is focused on the area outlined in blue, which is the Dickinson Bayou watershed. Our area is entirely in Galveston County, a large area southeast Houston. Tomorrow night we're going to focus on Clear Creek, which is in red. So tonight is Dickinson. So some more about the focus, just to set the table. I mentioned, and we're going to hear this a few times, this is a riverine study of regional magnitude. So depending on the kind of study you're doing, depending on the scale you're looking at, you use different modeling software. This project was based on modeling software that's focused on riverine analysis, that's looking at very large flows following a large channel. And so we are predicting things that are going to have impacts on the channel. There may be impacts that are happening away from the channel that are affected by the channel but not directly associated with it. So when we talk about damages and flooding, you might say, hey, my house or business flooded during Harvey, and you're saying your map's not showing that. Why is that happening? That's because this is just a riverine analysis. And one of the next steps we'll talk about towards the end is potentially looking at tying the localized storm drain capacity constraints into the analysis to fully predict what those things look like. We are looking at a 24-hour duration storm event with an Atlas 14 intensity. So the Atlas 14 is something that came from NOAA. That is the most recent rainfall data that is different than what the floodplain maps are currently based on. Even the newly adopted floodplain maps are not based on that rainfall intensity. So we're using the newest and best available data. The benefits that we're going to talk about tonight, as far as number of instances of flooding that are reduced and the damage reduced, is also going to be higher than what is presented in this study. So we have an even table with the damages caused by the flooding and reduced by them, but because we're not tying the local storm sewers, that there's a very high likelihood that those damages are going to be prevented in even greater sense because of those storm sewer impacts. So where are we? Again, we're in Dickinson Bayou. The analysis is focused on essentially a subset of the Dickinson Bayou watershed because we're looking at the riverine impacts. So the area in close proximity to the channel. We divided the watershed into 3 different reaches. The purpose of that was to support identifying and evaluating improvements in different sections of the watershed because the watershed is going to behave a little bit differently in different sections. So for example here, the section in red is what we're calling Reach 1, which is predominantly the area north of FM 517, which at this point is predominantly undeveloped, but a lot of development plans are happening in that area. Reach 2 is the area west of I-45, and so that's shown in here in green. So you've got some development along the bayou and north of FM 517 in League City. And then Reach 3, which is the area east of I-45, which has essentially the most historic development and the most population, the area east of I-45, and dominated by FM 517 and Highway 3. So when we talk about damages and instances of flooding and impacts, you'll see things presented in reaches, Reach 1, Reach 2, and Reach 3. So think about those happening from west to east as we go across tonight. So Rachel and Chuck set the stage, but just to reinforce, this is our 3rd and final public meeting for this project phase. We appreciate all the feedback we've gotten from everybody. This has been a bit interesting doing this through COVID. We had our chance to have our first meeting a little over a year ago, right before everything got shut down with COVID. So we're fortunate to have that done and have a chance to meet some of you in person. Fortunately, we have these tools that allow us to have these meetings and record them so folks can view them later. Hopefully we have a great turnout tonight. If not, as Rachel noted, this will be posted. And so please, your neighbors and friends, if they're interested, please direct them to this and have a chance to look at it. We'll also post questions and answers. The purpose of this is to share information and to get your feedback. The study is not final. So this is our final public meeting, but the study is not final. So we are presenting these concepts as drafts, as not final recommendations. So we do want your input on them. So please share those questions tonight, and we'll go from there. So where are we in the timeline? So we are at the end, right? Where we are wrapping this up. Initially, we were supposed to be done in May of 2021. We understand the sense of urgency. We understand that many of these problems have been studied for decades, and we don't want the study to go on for decades anymore. We want to get to the point where we can begin to work on these projects. So we pushed the deadline up a couple months. We've completed the modeling. We've completed the alternative analysis. We've completed ranking those alternatives, but that does not mean that there's not opportunity to tweak things and make improvements or engage in public feedback. So that's why we're here tonight, to get your guys' input on what we've proposed and what we think has a major impact, but we need your input. So the first step in the process of how do we fix the problem is understanding the flood risk. And so I'm going to invite our technical lead, Jim Keith, to talk a little bit about the flood risk analysis and some of the key takeaways from that.
All right, thank you, Brian. Assume you guys can hear me okay as well?
Yep, got you good.
Good. All right, good. All right, so we've talked a little bit about flood risk and the H&H modeling, the hydrologic and hydraulic modeling that's been going on throughout the study in some of our previous meetings. So now we're going to kind of focus on the outcome of that modeling. So Brian, if you go to the next slide here, what we focused on is really where are the problem areas? Where do we have damage and the greatest flood risk? So this map you see here is kind of a heat map that shows really where the most flood damage will occur based on the analysis. And obviously we've got some pockets, everywhere there is some development, but really east of Cemetery Road and especially east of I-45 is just a major damage center. And you're going to hear this affectionately referred to as the bowl throughout this presentation. And you'll see why in a minute. We'll talk further about that. The other kind of secondary damage center that we saw was kind of on the tributary of Bayou to the east. And so these damage estimates were based on estimated finished floor elevations of structures. Where we didn't have actual finished floors, we assumed that the slab was 6 inches above the natural ground. And so by intersecting all of that data, the building footprints, the estimated finished floors, with the outcome of the hydraulic models, we were able to compute these damage estimates. The other thing, you'll hear a lot of talk about these frequency events tonight, about the 10-year storm and the 100-year storm. But our models were calibrated to historical storms as well. So one storm, obviously, that we ran was Harvey. The map that you see here is the flood inundation that results from Harvey. And so we took high water marks that were obtained during that storm, and we used those to calibrate and validate the hydraulic model to make sure, obviously, that we can trust the model results. And that gives us a good path forward to then evaluate these projects. And so the black line you see here is the model boundary. Obviously, the Harvey flooding didn't just stop here, but the black outline is the boundary of our model. And again, like Brian already hit on this, but this is just the riverine flooding from the main bayou and tributaries. So we looked at both the existing land use as well as the future land use conditions. Most of you are probably familiar with the existing land use, and you can see from this map the green area is undeveloped land, and there is a lot of undeveloped land remaining in Dickinson Bayou. And that obviously it's changing right now as we speak. As you look at some of that area that's in that Region 1 is changing by the day. And over the next 50 years, we know it's going to look a lot different. So the next slide shows the projected future land use conditions. Most of that green changes to red. And so the population projections that we have and the land use projections for 2070, which is the future time frame that we're looking for here, project all of this area shown in red to be developed at that time. And this is going to significantly change the characteristics of the watershed and how much runoff flows and how fast it flows. One thing, because we're not able to predict exactly the timing and type of development and when and where that will occur, we can't really predict, what kind of detention may happen. And so our analysis is very conservative, where we don't assume any detention will happen. And this is really a worst case scenario, and in a lot of ways it just kind of is a good reminder of why detention is important. So if detention requirements are strictly enforced, our full build out or future condition scenario here is going to kind of overstate things. But as we move through the rest of the presentation, we're going to stay focused on the future land use conditions and those results. So the model results here we're showing are the 100-year peak discharge. And peak discharge is reported here in CFS, that's cubic feet per second. And to visualize what's a cubic feet per second, that's about a basketball of water flowing past every second. So if you look at these numbers, you can see down by the time we get to Bayou, we've got peak discharges of over 20,000 basketballs moving past every second. So this is a significant volume of water. The comparison here shows the FEMA effective discharges, as well as our new existing conditions, which is based on the Atlas 14 rainfall. So you see some increase already there in terms of what FEMA had previously modeled and our new model based on the rainfall data. And then the future discharges, which again do not assume detention, but you're looking at 6 to 7% increase in discharges between just existing and future conditions. So how do we kind of convert that flood risk, those numbers, into damages, which really kind of helps us understand the challenge that we have to solve here. And so what we did is kind of bookend the problem between a 500-year storm, which we all know you guys have suffered major storm events in this region. And so we know we need some solutions to reduce flood risk during those types of events. And then we look down to a 5-year storm, which is a pretty frequent event. But you can see in the Dickinson Bayou watershed, there's still a significant number of structures. Over 1,300 structures are flooded in a 5-year storm. And so this window here is what we're calling our area of benefit. Structures that are flooded in a 5-year or below storm events are really unlikely to benefit from any kind of structural improvements that we're proposing. They're too low in the floodplain to really see any kind of impact. And so those types of structures are typically good candidates for elevation or buyouts, what we call non-structural improvements. So we're focusing our area of benefit and our solutions on this zone of damages that can be mitigated between the 5-year and the 500-year storm. And you can see that's $765 million worth of damage and over 13,000 structures. The other way, you've seen the view of the flooding from above in some of the previous figures, looking down on the floodplain. This image is a little different. What we're looking at here is a profile of Dickinson Bayou, looking at it kind of from the side. On the left, you'll see the green line is State Highway 146. And as you move to the right, we're working our way upstream. Just imagine you're going up the main channel of Dickinson Bayou, past I-45 up to Cemetery Road. The red line is the 5-year flood elevation. The blue is the 100-year. And the purple line is the 500-year flood elevation. And all of these tiny X's that you see across here are structures based on the estimated finished floor elevation. So we found this graph to be really informative and a really good way for us to look at the flood risk through this watershed. You can see that there are a significant number of structures, especially between State Highway 3 and I-45. There it is. There's the bowl. There's just a low, depressed area here. And so it helps us understand not only just the extensive flooding, but really the depth of flooding that can impact these structures. And the damage estimates are really driven on that depth. The Corps of Engineers provided depth damage curves that we used. And so obviously as the depth of water in a structure increases, that damage increases greatly. So these two circles here show, again, kind of in side profile view, the two areas we're really focused on reducing flood risk in this study. That's the bowl and then that Gum Bayou tributary. So here's a shot of the bowl. This is the old downtown Dickinson area. And this green area here, you can see is pretty much surrounded entirely by yellow. And so there's just a depressed area here where all the water comes together. The other factor is that not only does Dickinson Bayou come through here, but you have several other large tributaries that come through. The Borden Gully, Magnolia Bayou, Benson Bayou, all three of those come together here. And now you've got a lot of water coming in, and you've got this depressed area with kind of a restricted flow path out to the east to get downstream. So this became a really challenging area as we started to look at these mitigation solutions. Brian's going to talk about that in a little bit, but getting water out of this bowl is a major challenge. So the results of the flood risk assessment, again, we broke the planning area into these three reaches. You see here DB1, DB2, DB3. And so we looked at the number of structures flooded on individual events, so just for the 500-year or the 100-year event. But what's really informative for us is to look at the instances of flooding over an entire 50-year period. And so what this is a statistical projection. If you look at over a 50-year period, how many you're going to get 2-year storms, 5-year storms, 10-year storms, you're going to get a 500-year storm. If you look at that 50-year window, you can see the instances of flooding stack up. And so the results show that we'll have over 43,000 instances of flooding over that 50-year period with a damage of $483 million. And really more than $483 if you factor in all the reaches. So the damages and flooding instances increase in the future. And part of that is due to sea level rise as well as future development. So another area that the Corps of Engineers helped us with is sea level rise projections. And those projections were incorporated into the downstream boundary conditions of the model. So beyond just kind of the number of structures and damages, we looked at transportation system impacts. Transportation obviously affects us, during a storm event. It affects you getting around town, getting able to pick up your kids, for emergency responders to get to people that need help. And so we used an established flood hazard calculation that's done by the U.S. Bureau of Reclamation that looks at the depth of flooding over roadways and then how fast that water is moving over the roadways to provide a hazard classification between kind of a low danger zone, a judgment zone, and a high danger zone. And so these dots on the map, basically green circles are areas of lower flood risk, and red triangles are areas of the highest flood risk. I think the good news here is that most of those red triangles are small rural roads. But again, you can see some major thoroughfares are impacted in some of these events. And then we also looked at critical infrastructure. So this is fire stations, medical facilities, hospitals, schools, and major water infrastructure, treatment plants, pumping plants. And this is also an important factor as we look at where we can reduce flood risk. We need to make sure that in major storm events, these critical infrastructure locations are able to function or protect people. So the blue area shown here is the 100-year storm event. And so you can see along FM 517, there's several schools that are at risk, as well as some water infrastructure and some hospitals there to the north. So to kind of summarize the flood risk segment here, the flood risk in Dickinson Bayou is significant, and particularly in Reach 3. You can see we have, in the 500-year event, well over 14,000 structures that can be flooded just in that single event. That's not even over the 50-year period. That's just in a single event. And $1.7 million, or sorry, 739, $1.7 billion of flood damage for a 500-year event. And so we used these damage estimates and looking at this curve to look at, okay, where can we get our best bang for our buck? What kind of projects can we implement that can reduce not only just the large 100-year and 500-year events, this 10-year event as well, where we still see significant flooding in the watershed. So with that, I'm going to hand it back to Brian to start walking through the mitigation alternatives.
Thanks, Jim. Appreciate you walking us through that. Before we jump off the slide, I do want to, one thing that attendees might find interesting is, where are the orange bars, right? I see Reach 1 with an orange dot. Why is nothing happening in Reach 1? At this point in Reach 1, there are very few structures to flood. It's not that flooding is not happening in Reach 1, it's just not flooding very many structures. So it is important that as new structures are built in Reach 1, that they are built at an elevation that they will not flood, right? Setting those elevations based on known flood maps is really important, and making sure that their neighborhoods or structures that they don't flood is critical, because right now, the only reason things aren't flooding in Reach 1 is because nothing's built there yet. Otherwise, it would look similar to the other two reaches. All right. So we've established the flood risk, which is significant. So let's talk now about how do we mitigate it? What are the mitigation alternatives? So before we jump into those alternatives, we need to talk about how we're going to evaluate them. So we have 4 different quantitative metrics, and Jim walked through these on the damage basis, but we're going to now evaluate these on how much they benefit those damages. So instances of flooding, how many times a structure is inundated during the 50-year project horizon period, which that is a statistical analysis that accommodates the 2, 5, 10, 50, 100, and 500-year storm events, and looks at how likely they are to occur in a 50-year period. Structural damage, same thing. It looks at the value of the structure, uses an Army Corps guideline for depth of flooding to determine how much damage that structure incurs in that event. Then we'll talk about capital cost. How much is this going to cost to build? And then transportation system impacts. How much better does the transportation system function with the improvements over the existing conditions? And another thing to note, we talk about instances of flooding. I mentioned that this is all structures that exist today, right? Not future structures. Same with structural damage. We're looking at current property values, current structure values on those sites, as well as current elevation. So if structures in the future were raised, that would obviously take them out of the floodplain as well. All right, on a qualitative basis, we worked with the stakeholder groups to establish what we're calling non-cost factors. Everyone, I think, can appreciate that just the cost of a project and how many structures it benefits or doesn't benefit is not the only metric. Obviously, how it looks and feels, how much it disrupts the community is all very important information. How resilient is it? Is it going to work for 50 years without a lot of maintenance? How many people does we have to get on board to do this? Is it kind of how we comply with other agency coordination? And how fast can we implement this? Is this a 10 or 15 or 20-year permitting project, or something we could start today? That also kind of ties into how expensive is it? Is it something we can finance quickly, or have to spend a lot of money over time to build? So we looked at those factors. We weighted them with the stakeholder groups. They all weighed out similarly. The kind of four leading categories there, and then other agency coordination comes in at 10%. So all of the criteria were applied to all the different projects, and that's what we'll be presenting today. And when we produce written report, we'll have a lot more detail backing up how each of those scored. We also established a couple different constraints in order to help put boundary conditions on the analysis. For Dickinson Bayou, there were 2 constraints. The first constraint is that we are not going to cross I-45 with any sort of open cut solution. That would look like some sort of channel or a major culvert. We're not going to cross I-45. That is a major disruptor for the community. And some might say that that's an unnecessary constraint. I think that we have this is somewhat informed by the analysis that we think we can create benefit downstream and not need to cross I-45, but doing so would be a major impact, and so we wanted to avoid doing that. We also did not want to widen or modify the channel on Dickinson Bayou east of Cemetery Road. Having been on Dickinson Bayou in a boat, it is a fantastic waterway. It has a lot of aesthetic benefits, a lot of community benefits. A widening project there, also a lot of homes that back up to the bayou. We did not want to disrupt that as part of this analysis, so we're looking for solutions that did not widen or modify the bayou east of Cemetery Road. So with those constraints in mind, this is a list of all the different individual concepts that we evaluated. So a lot of different detention alternatives, some bypass alternatives. We looked at clearing and desnagging of the channel, which is essentially removing vegetation along the channel banks. We suggest, in some cases, property buyout elevation for properties that, as Jim mentioned, that are so far in the floodplain that cannot be realistically improved by other structural measures. And then we will spend a couple minutes talking about a flood wall, which is an interesting concept. No bridge modifications were deemed to be a problem. We looked at all the bridges, and we looked at how they reacted during different flow events, and none of the bridges had major impacts for passing water based on current conditions. So that's a good thing. And we did not have a tunnel alternative for Dickinson Bayou. Dickinson, because of its current state of development, is a good candidate for detention, particularly west of I-45, and in some cases a good candidate for a bypass because of the lower density development. Tunnels are generally useful more so when we have high density development. So tunnels were not going to be cost effective in this measure. We could move and store water more effectively in other metrics. So those are different individual concepts we evaluated. We're not going to walk through each one of those and their benefits tonight in this meeting. We will walk through each of those in detail in the report that will be published. But tonight we want to focus on how these concepts play together to create a combination solution that has the most value. So first thing we're going to talk about is one that we haven't cited individual properties for this, but as we talk through these alternatives, and Jim showed the bar charts, structures that are flooding in the 5-year event are going to be very challenging for us to mitigate. You very quickly begin to realize that no matter how much bigger you make infrastructure, how big you make a bypass channel, or how big you make a detention basin, that eventually you can throw a lot more dollars at it and not have a lot more benefit. And that's this kind of area in gold you see on the map, or on the slide right now. Those structures that are at or near or below that red line, which is the 5-year inundation profile, are candidates that need some other solution. That might be elevation, that might be voluntary buyouts, but those structures are going to be very hard to protect. Now, in some cases, I think those structures may already be elevating. We did not do a property-by-property survey for these X's. We looked at the LIDAR and looked at 6 inches above the LIDAR elevation for base slab. So that's important. We did a lot of Google Street View to verify things, but there are maybe some structures here that are actually at a higher elevation. The good news is we have the ability to fix these with sometimes localized improvements, right? Elevation of a structure, getting out of the floodplain. Those are things, certainly if there's another flooding event, we don't want to rebuild structures at the same elevation in those locations. I'm going to talk through 2 of the individual solutions because neither of these solutions are included in the combination analysis, but both are things that may want to be investigated further. So Jim noticed us on the Gum Bayou Tributary Diversion early in the presentation. This area that's just east of Dickinson Avenue, it feeds into Gum Bayou and then goes into Dickinson Bayou. It is a hot spot for flooded structures. There's a lot of structures at very low elevation here. We looked at this because of that preponderance of structures on how can we solve this. The challenge we have is our project was focused on the main channel, and with this solution, because it's so developed, there's not a great spot for detention. It could have a big impact. It's also very low in the terrain area, so it's not a good candidate for detention. But the solution here could be improving Gum Bayou's conveyance capacity, or potentially creating a bypass down to Dickinson Bayou. The problem when you do that is, as everyone knows, we can't create downstream impacts. This is the project that is something that we can evaluate in a future phase, that if we're able to initiate some of the improvements that we'll talk about in a few slides, that this area here, East Dickinson Avenue, could be relieved through a new conduit down to Dickinson, and not have those downstream impacts. So it was not specifically modeled. It's really more of a storm sewer network solution because there are homes at this California Avenue, our homes along here. We're not advocating building a channel through those homes, but maybe a large storm sewer system. That's something we could evaluate in the future with some different modeling technology to look at storm sewer impact. We also talked about the flood wall in the bowl. So the bowl is the biggest problem. As we'll talk about in a few slides, we were able to reduce the water source elevation in the bowl by a few feet. The problem is many of the structures in the bowl are flooding with 5 or 6 feet of water. So although I think people would be appreciative if water only flooded their home with 3 feet instead of 6 feet, 3 feet of water in your home is still 3 feet of water in your home. And although it might be your upper cabinets don't need to be replaced, it's a big problem, right? So what else could we do? A bypass channel by itself does not mitigate this. So we looked at the potential of trying to use FM 517, which is about elevation 11, as a barrier for the stretch between I-45 and State Highway 3. There are nearly 200 structures worth about $20 million that have a slab elevation of 6 feet or less in this area. So there's a lot of very low-lying structures. And right now, those structures along the tributaries of Borden, Magnolia, and Benson are flooding because of backwater effects from Dickinson Bayou. So could we isolate them from Dickinson Bayou? The short answer is yes, we could isolate them. The long answer is to do so is going to be very expensive. and require a system that is going to be very operation intensive and maintenance intensive and challenging. The goal here would be to eliminate the backwater effect of Dickinson Bayou, keep the Dickinson Bayou from flooding these tributaries, right? To do that, we could potentially use FM 517 as a flood wall. It is not a levee, right? It's not designed as a levee. Try to use it as a flood wall. But that would require you to build a closure structure and a pump station. These are all very large pump stations, over 2,000 CFS. This is likely a $200 to $250 million solution, and it only provides about a 10-year protection, because once Dickinson Bayou goes over 10-year elevation, FM 517 gets overtopped, right? And so water is now flowing over the top. So we looked at this more after we found that out and said, okay, well, how high do we have to make FM 517 in order to make it safe, right? How could we modify this to create a remap in the floodplain, right? To take all these folks who live here out of the 100-year floodplain. And the answer is it needs to be about elevation 17 feet. So I don't know if folks in Dickinson know what elevation they're standing at along different parts of the city, but there's no land that is elevation 17 feet in Dickinson. So you're talking about having to build a ring levee, and costs begin to spiral pretty quickly. So this is a solution that can be looked at, but it's something that we'd have to find a way to tie in after the potential Texas coastal study puts in some sort of surge gate on Dickinson Bay. The reason that 17 is an important elevation is that's 3 feet above the 14-foot elevation, which is the surge elevation from FEMA for this area. So this is a project that we should kind of keep on the burner for the future, but not one that our rainfall study is going to be able to address because of the coastal surge impacts that tie into the area. So all of the other individual mitigation analyses, here are some of those metrics we looked at. So this is color-coded in effectiveness, right? So the greener the cell, the more effective it was. So we looked at 3 different bypass channels of different conveyance capacities, 1,800 CFS, or sorry, 1,100 CFS, 7,500 CFS, and 8,500 CFS. We looked at multiple different detention ponds, and we talked about how many instances they reduced, how much you're paying per instance, right? How many flooding instances are reduced per dollar? Do these things cause downstream impacts have to be mitigated? How many $1 million of flood damage reduction happens? And what's the capital cost, right? And then we have those non-cost factors. So detention ponds, particularly on open land or land that potentially be purchased for sale, score pretty well. Solutions that require a lot of land acquisition, like the bypass channels, score poor because of that. Now, this is only a 100-year event analysis. So if you're looking at a benefit cost analysis, you're looking at the whole suite of storms for the 50 years. So when we see this flood damage capital cost of 0.5, that's not a 0.5 BCA necessarily. That's just how it performed in the 100-year event. So what we have now is kind of a multiple different options, right? A suite of solutions. The question is, how do we utilize that suite of solutions in combination to benefit the area and to the maximum level? So some conclusions that we came up with in the analysis. Individual detention improvements provide localized benefits, which is good, but as we found out during Hurricane Harvey, detention ponds have a limited value when you get into a multi-day storm event because they fill up, they take a long time to drain. I know the detention pond near my house filled up, and it takes about a week to drain usually, right? So if we have a storm event that happens back to back or even over a couple days, that detention pond can't handle a multi-day storm event. So detention is good, but not as good as conveyance. Although the water surface is reduced by multiple feet with the bypass channels, even with that large diversion, we're getting flooding still happening in the bowl, right? That's when we talked about the flood wall. The other thing that's important, because Dickinson has available land, we've got that regional detention opportunity on Dickinson Bayou that we don't have in our own study area, talking about Clear Creek, that doesn't exist anymore. So we need to identify areas for regional detention and plan those and get those lands set aside and built before development occurs. The bowl is likely to need extensive elevation of structures, buyouts, or a flood wall, or some sort of stormwater pump station system. That area is extremely challenged. There were a lot of structures that were built very low in that area that today we would not build there, and we have to find a way to protect them or move them or raise them up. So some kind of overarching conclusions. the combination solutions are necessary to maximize benefits. There's no single project that solves all our problems. And to realize the full benefit of mitigation, we're going to talk today about, again, watershed-wide benefits, focus on the channel, but to really get the full benefit of mitigation, we need to take the whole drainage network into account. So all the storm sewers that tie in, all the small culverts that tie in, are dramatically affected by what elevation Dickinson Bayou is. And so if we reduce that elevation by 3 feet, all of a sudden, all the rest of the drainage system works better. And so those benefits aren't accounted for in these numbers you're going to see tonight, and something we can work on in the future. All right, so let's talk now about some of those combination mitigation measures. So for Dickinson, we looked at 2 different scenarios. One of those scenarios focused entirely on detention. Can we build detention west of I-45 at a level that will allow us to prevent damages to the bowl and other areas? The second scenario said, okay, we're going to build all that detention that we talked about, but we're also going to build a very large diversion channel that's targeted at the bowl and to move flow further down into Dickinson Bay. So the 11,000 CFS diversion channel represents about a 50% diversion of flow from, or actually greater than a 50% diversion of flow from that area where those 3 bayous come together. So a very large diversion channel to try to pull that water source elevation down and provide benefits. So what you're going to see in the next slide is a colored raster plot, which is a comparison between the condition without the improvements and the condition after the improvements. So this is the detention scenario. So we have 4 different detention areas, actually 5. Number 4 has 2 areas, and that paired with buyouts. The buyout cost is not included, or structures not identified specifically, but those are areas that could not be benefited would be something we talk about for buyouts. So let's talk about each one of these individually. So the first basin, we'll start at the west and work our way to the east. The first basin is called, we named it the McFarland Road Detention Basin. It is north of FM 517. It's in the proximity to some new developments that are happening in that area, but not in an area that would overlap with the development. So it's been sited on kind of unused or unspoken for land in that area. It is, if folks are familiar, there's a bypass channel that comes off of Dickinson north of FM 517. It's actually located on kind of where that bypass channel exits and then crosses FM 517. The second basin is called, we're calling Cemetery Road West. It's at that confluence where the bypass channel comes back into the main channel. These 2 basins are large, much larger than the basins as we get further to the east. That's in part because there's more available land, and detention is most effective when it's provided kind of in the upper part of the watershed. So 90% of the total storage is provided in these 2 basins. They're of similar size. As we go further to the east, we hit number 3, which is we're calling the golf course or Hilton Lane detention. It's on the south side of the bayou. It's a property that was a former golf course that's no longer operating after Hurricane Harvey. It does provide some benefit, but it's more localized because it's not nearly as large of a basin. And then we have 2 basins that are paired here right before Magnolia Bayou and Borden Gully cross I-45. There's some available land, hasn't been developed there yet. Turning those into small detention, even though they're quite small, actually do provide some localized benefit to those neighborhoods there, and do limit some of the flow crossing into the bowl. So in total, that it's about 5,200 acre-feet of storage. So in Houston fashion, we have to measure things in terms of how many astrodomes of something that is. So that is about 5.5 astrodomes full of water that these 5 detention ponds account for. So as you can see on this chart, the light blue is a reduction of about 1 inch of water source elevation. So over a very large area, the water source elevation is reduced, but it's only reduced by 1 inch. The next color, kind of the darker blue, is showing water source elevation between 1 inch and 6 inches reduction. So we do see some areas that have a more substantial reduction. And then there's some smaller areas that have, you see the darker blues, and even purple, where the water source elevation is reduced dramatically. We also have the non-cost factor scores here. So these detention ponds are all kind of individual projects, could be developed. They don't have dependencies. Detention ponds can be developed in a way that provides recreational use, whether it's a wet bottom, which provides a more of aesthetic view, or could create it as a recreational field opportunity. They're very resilient structures. They're tried and true design. Doesn't require a lot of operation. It could be implemented very quickly, but we get a 2 for land acquisition because there's a lot of land that has to be purchased. Even if it's something that's not operating, it's still a process that has to go through, and it commits that property to that use and nothing else. So one of the important things on flood control is how do we sequence it. The detention scenario is good because it doesn't require us to have dependencies. So each of these projects is self-mitigating. There's no downstream impacts from any of these properties. So they could be implemented in any order that is feasible. So whatever project is most available, land most available, easiest to start, that project could start independently of one another. All right, so where does the rubber meet the road? How do these perform quantitatively? We talked about the flooding instances by event, right? So in a 500-year storm, we had 14,600 instances happening. Well, what happens now that we have the detention pond? So the red bars are future conditions, no mitigation, and the purple lines are future conditions with the detention mitigation. So we see in a 100-year event that there's 500 less instances. That means 500 less structures are flooding the detention ponds. We see a reduction in damage of $36 million in a 100-year storm. We also see a reduction of water surface at I-45 of 0.37 feet. So over the 50-year design period, looking at all these storms, and they're probably only happening 50 years, we see almost 2,500 instances of flooding prevented and $41 million in damages. So looking at some different efficiency numbers, how you look at that. So every $1 million of investment would prevent 11.3 instances of flooding, which if you flip that around, for every instance of flooding, you spend $90,000. So that's how the detention concept measures up on quantitative metrics. So what are the takeaways there? Because there's so few structures west of Cemetery Road, we don't actually see a lot of structures being benefited. We see a lot of detained water, which is good, but sometimes detention has the biggest impact right where it's located. So since there's no structures there, quantifiably it's challenged in that sense. Even though water is being detained, there's not a lot of structures right there. As I said before, open land is available now, so let's set that aside and make it for regional detention. Storage alone, unfortunately, doesn't impact the bowl, right? If we jump back to that, we're having very little impact on some of these 10-year events. That means we're not impacting the bowl. That's a lot of that stuff's happening is east I-45. And significant residual risk is existing even with those improvements. So we got 5,200 acre-foot of storage, which is a substantial amount of storage over those different basins, 5.5 astrodomes. And we are having improvements, but as a team, we looked at it and said, hey, that's not good enough. So what else can we do? So the next step was to look at the second scenario, which is let's build all the detention and let's build a conveyance system. So this is what we're calling detention plus channel. So it has all the detention we just mentioned, as well as a diversion channel that begins kind of right at the nucleus of that problem area, right where Borden Gully and Magnolia Bayou and Benson Bayou come in, Dickinson Bayou, and it conveys that flow to the east across Highway 3 and the Union Pacific Railroad track, and then follows an existing channel out into Dickinson Bay. So what does that look like? Well, you can see the color scheme change quite a bit. Instead of having wide areas of very light blue, we have a huge area of a 2 or 3 foot reduction in water source elevation in the maximum impact area. We also have benefit propagating west of I-45, where we have 1 to 2 feet of benefit all the way back past Cemetery Road. So a dramatic increase in benefits. We do have an increase in cost, right? This channel does have to be constructed. It is approximately 500 feet wide, so this is a very large channel. We are not proposing building the Los Angeles River through here, the large concrete structure. This is something that could certainly have an amenity benefit for the area, but it is a very large channel. So football field, 300 feet wide. So this is a wide flood control conduit. At 11,000 CFS, again, we're talking about astrodomes. That's at 11,000 CFS, that would fill up the astrodome in 1 hour. So we talked about the detention, right? 5,200 CFS, 5,200 acre feet flood of detention. But at 11,000 CFS, that fills up in 5 hours. So this 11,000 CFS conveyance improvement allows us to move water out of the system perpetually, no matter if the storm lasts an hour, 24 hours, or 72 hours. One thing that's important to note, this bypass channel is showing downstream impacts, both at Highway 3 and at the discharge location. Those impacts are something that is not acceptable, right? We have to mitigate those. So that's a couple ways to do that. Number one would be modifying the outlet structure here, providing some flood protection, some backwater protection for this area. This one may just be some perched water that you can maybe get into the channel. Another option would be to try to purchase some additional properties to keep it from flooding. But obviously, we don't want to move the problem downstream, and what we're showing with this preliminary analysis at a high level is there is some impacts that would have to be mitigated. From the non-cost scores, we're scoring this as a 1, right? Land acquisition, this is going to require a 500-foot plus wide path to get us downstream. Because of that, it's going to have some impact on community. This is a relatively rural area, but there are structures and homes along this route that will be impacted. We have to cross railroad track, cross Highway 3. But the channel is a gravity flow channel, right? It has a very high level of resiliency and really improves the operating of the system substantially. So I think our team would like to say that this is a great idea that we came up with all on our own, but in reality, this is a concept that has been thought about on Dickinson Bayou for a long time. So this is a figure from 1994, which shows in red here, if you guys can follow, we have Dickinson Bayou bypass channel. At this point, crossed I-45 and went all the way kind of almost the upper area of the Dickinson Bayou. We are really kind of recreating this eastern section that was initially proposed at least in the 90s, if not earlier. So it's been talked about a long time, and we're hoping that we are at a point here we can help make it come to fruition. So how do you sequence this? Just like the detention ponds, each of these are self-mitigating with the caveat on the diversion channel that there's going to have to be some downstream impact mitigation as part of that project. But the detention ponds can still proceed, and the bowl diversion channel can proceed by itself. So let's see how this stacks up quantitatively. So we had the construction cost increase from $220 million to an estimated $500 million to construct. But all of a sudden, our damages that we prevent go down substantially. So now we're looking at over 2,000 instances of flooding eliminated in the 100-year storm, $146 million. We're talking about almost a 2.5 foot drop in water surface at I-45, which is a huge number. Over a 50-year life, this combination diversion and channel improvement would prevent 15,000 instances of flooding and $245 million in damage. And that's not even accounting for the localized perched water that can't get to the channel because the storm sewers are backed up. So we went from 11 instances per $1 million to now 30 instances per million, and now only $30,000 per instance of flooding reduced. So 3 times the benefit by adding the conveyance channel. So just to call attention to this, I mentioned it earlier, but there are 60 to 70 structures that are impacted based on kind of the conceptual layout of this. That's something that will have to be refined and improved as that concept goes forward. All right, so some takeaways on this concept. A huge number of structures are removed from the flooding risk. So we've got 15,000 structures over a 50-year period. We got to mitigate those downstream impacts. Even though we have a 2 foot or more reduction in the bowl, there are still a lot of structures flooding. Even with that reduction, there's still 1,800 structures in a 10-year event that are flooding. This goes into the Jim's comment earlier that there's some structures that just cannot be helped, even with massive bypass channels. That bypass channel is taking out almost more than half of the flow out of Dickinson Bayou, and there's still structures flooding in the bowl. That's a sign that we have to do something else in that area. And then, $30,000 per instance is the best of any of our combination analysis we did as part of the study. So it's getting to a point where it does provide quite a bit of value for the improvement. All right, so some conclusions, some kind of key takeaways. We're getting closer to the end here. I appreciate everyone's attention and comments we're getting in the Q&A. Get to those when we get done with the presentation here in a second. So Combination water source elevation profile. So you guys saw before the red line, right? So our red line's different now. This red line is the 100-year event, no project, right? The purple line is if we build detention only. And so it might be a little hard to see. Well, again, we're going to publish this slide deck for everybody. You guys can dig in and zoom in on it later. But we got, a foot or so reduction. It starts to dissipate as you get towards I-45. But, substantial water source elevation reduction. 5,000 acre feet is a lot of water retained. But not nearly the impact you see from the blue line, which is, that, zooming in here a little bit more, the bypass channel intake is right there at where that inflection point is. Major reduction compared to the detention only, and really targeted at the area of maximum damage. It also would allow this Gum Bayou area that has a problem to convey flow to Dickinson Bayou and still be below the existing conditions. So it allows other drainage to happen to Dickinson Bayou that right now can't get there. So comparing those bar charts, same color scheme. So red is no improvement, purple is our detention, and blue is with conveyance. You can see that a couple things from this slide. Number one, that the blue is significantly better than just detention only. But there is still a lot of structures that are going to be damaged. Dickinson is built in a low-lying area. We have impacts from storm surge. We have impacts from Galveston Bay being at a higher elevation. And so some of this flooding is unfortunately not mitigatable, no matter how much conveyance improvements you provide. But we can substantially make it a lot better. Another area to focus in on is this, again, 5, 10, and 2-year storm events. We've got to find a way to mitigate those. And even with our massive channel and detention project, we still have a lot of flooding happening. 1,800 structures and over $65 million in damage happening in the 10-year event. So the bowl is improved, but it's still a problem area. We had almost 3 feet of water reduction, but there's still more improvement that has to happen there. So that's looking at buyouts, property elevation, and potentially if the Texas Coastal Study happens and we get a storm gate on Dickinson Bayou, then there's an opportunity to try to look at a flood barrier with FM 517 as well. These benefits don't fully account for drainage impacts. That's something that can be tied in later to fully build up the benefit ratio as part of a benefit cost ratio analysis. The 50-year project window is important, right? That's how you calculate a benefit cost ratio, but it penalizes the impacts from those major storm events, right? A 500-year storm is not very likely to occur in a 50-year project window. Same as a 100-year storm, not very likely to occur. A 50-year storm is going to occur once statistically, right? So smaller events happen more often. Those are prioritized as part of the benefit cost situation, but our analysis is focused on 2 things. One, maximum benefits, and also how do we mitigate major storm events, right? So the 50-year window is a statistic, but it's not the whole story. Significant residual risk does exist east I-45 due to those low-lying structures, and you begin fighting sea level, right, and storm surge. When the downstream elevation is high, there's sometimes very little you can do. It costs a whole bunch more money to move a little bit more water. The diversion channel is the most cost-effective solution that we analyzed. Storage alone is effective, but not nearly as effective as when it's paired with a conveyance improvement. And that conveyance improvement is not duration dependent. So, for example, Harvey lasted multiple days. Conveyance improvements will keep moving water every day, all day, and never get full. So that's a significant benefit. We were not trying to target benefits for 2- and 5-year storms. It may be an opportunity that local City of Dickinson or City of League City Studies can provide some more benefits on those smaller events. We were really focused on mitigating the 100- and 500-year storms as part of this analysis, and that's why we sized the infrastructure on the large size to pick those up. All right, so we talked about the what, right? The what is we need detention and conveyance for Dickinson. The next step is how. How do you do that? And the biggest question mark on the how is how do you pay for it? $220 million or $500 million is a lot of money. And so how do we establish financial partnerships with local, state, and federal entities to get those funds? There's a lot of different partnerships available. There is very rarely free money, like the saying that there's no free lunch. Most of these programs require some sort of local match that can be a pretty significant percentage. And even if it's not a significant percentage, if the total cost is significant, say $500 million, even 20% of that is a significant sum. Also, many of these programs are going to have strings attached, sometimes contracting rules, financial reporting. Sometimes the project have to meet key metrics. As these programs are pursued, it's something that we need to be careful of, that we understand the implications of these program requirements and make sure that it's a worthwhile partnership, both for the sponsor entity and the receiving entity. One example, there have been some newer programs developed since Hurricane Harvey that have put a significant emphasis on low to moderate income areas and socially vulnerable areas. So the Bowl and Tributary Dickinson Bayou are both areas that could qualify potentially for LMI, which is low to moderate income, or SVI, which is social vulnerability index areas, and look at specialized funding for that. So who are the partners? These are familiar names for most folks that have talked about flood control, but in front and center, the Army Corps of Engineers, Galveston District, they are a partner as part of this study, a very helpful partner, particularly related to sea level rise and storm surge. Large civil work projects for flood control have often been done by the Corps. We also have FEMA, which is often in the past has been more responding to storm events after the fact with damages, but has taken a more proactive role in the last 10 years. We have the Texas GLO, which is helping implement some of the programs on a federal and state basis. We've got opportunities through the Texas Water Development Board, U.S. Department of Agriculture, and the U.S. Department of Housing and Urban Development, which is some of the projects that are happening with the Texas GLO. So multiple different state and federal partners. Like I said, each one has different criteria. Some of them are loans, some of them are grants, some of them are partnerships. An opportunity that almost on a case-by-case basis, as we said, we have a suite of solutions, right? A combination analysis of detention and conveyance. The solution may be that one of those detention ponds may work well for one program, another one might work well for another program, that conveyance system might work well for a different program. It may be a bit of an a la carte method to find the right partnership opportunities. So, as I kind of mentioned earlier, external partners are helpful, but they also bring additional complexity. So we need to understand that it's a win-win. Most of these programs are going to focus pretty heavily on benefit cost ratios. And so that's why our analysis focuses on riverine flooding impacts. We need to be able to tie in and loop in those local flooding benefits. That's working with each of the municipalities and any drainage consultants they have, understanding how a major reduction on the bayou could provide benefit to their local drainage structure. Make sure we count all those benefits as part of our project as well to get those numbers up as high as possible, because if our benefit cost ratio doesn't get over, say 1.0, the opportunity for some of that, especially federal aid, becomes more challenging. But we talked through different contracting procedures, which may require the entities doing the project to operate a little differently than they would otherwise. So other people's money is helpful, but it has a lot of strings attached. So the other thing to think about is how could we create a local funding opportunity for this project? There's a lot of different ways to do this. Sometimes it's a municipal project, city funds that are applied, or city bonds. But one thing we wanted to talk through is the idea for we'll call it Dickinson Bayou Flood Control District. So this would be a special purpose capital improvement and operations district for the main channel Dickinson Bayou to mitigate flood impacts. This entity could be the local sponsor for federal and state partners. So this entity would partner with existing drainage districts that exist, so Galveston County Drainage District number 1 and number 2, as well as municipalities along the creek, so City of Dickinson, City of League City, City of Texas City, City of Santa Fe, Alvin, and others. The district would be set up and generate revenue through an ad valorem tax on property in the watershed. So currently there's about $7.5 billion of property in the Dickinson Bayou watershed. That property, if this district was established, and had to be established by the state of Texas, initially in the legislature, and then it would go to a local vote for all people in the watershed that would be affected to give it taxing authority. It could exact a property tax on the people in the watershed that would be directed specifically to fund flood control improvements. The board of the district could be established in any way that made sense. Sometimes it's appointed, sometimes it's elected by different people. So there are examples of this throughout the Houston area. But this is an interesting opportunity for Dickinson, because since there's so much property growth that'll happen in the next 20 and 50 years, even though there's only $7.4 billion of property in the watershed, and comparatively speaking, there's almost nearly $50 billion of property in the Clear Creek watershed. That's going to change a lot over the next 20, 50 years. So there's opportunities for increased project funding over time. An example that's been in the news just the last few days is the Gulf Coast Protection District. So this is a special purpose district that's being proposed in legislative session to fund the Texas Coastal Surge Protection System. So its charter would set it up to fund Brazoria, Chambers, Galveston, Harris, Jefferson, and Orange County improvements, and would tax those entities accordingly. It would be appointed by the governor, and it would not only provide the local match for a federal project, but also be in charge of the annual maintenance on the project. So as an example, it's been set up before. Gulf Coast Protection District is something that could be a model for something smaller scale for Dickinson Bayou. All right. I get the break of talking and get to hand it over to Chuck Wolf, who's our moderator tonight, and he will take us from here.
Okay, thanks, Brian. You can take a quick break. So wanted to just discuss quickly what our path forward is on the program. Hopefully everybody can hear me. And then we can open it up. We've been able to address some of the questions as we went through the Q&A. But we'll be able to, as we went through the presentation, we'll be able to go through other questions as we go forward. So why don't we go to the next slide, Brian? So as Brian mentioned earlier, we're done with a lot of the analysis, and you've seen some of the recommendations that have come out of that analysis, but we're not entirely done with the study. Part of tonight is getting your input, as well as input we may get over the next week or so, as you get to reflect on it, look back on the material, dive into the material a little bit deeper. But we want to go ahead and take that feedback, and we'll finalize these combination alternatives into solution sets based upon feedback from tonight's meeting and other feedback that we get over the next coming week or so. With that, we'll work on finalizing the study. We'll put together written documentation, including our recommended path forward on the alternatives. And then we're also going to be working on identifying the needs in potential future study phases. As you know, this is a watershed study. Even some of the questions that have come in so far through the chat, there's been input and questions about, what would be next and where in the design phase you may get to certain answers. So we'll be working on some of those recommendations to assess the benefits to local drainage systems, as well as increasing the project benefit metrics. As Brian mentioned, our study is riverine focused. If the riverine watershed or the improvements are made, that lowers that level. Everything else works better too. That's a different kind of modeling that would need to be done to be able to assess those target areas. So those are some of the things we'll be doing for the next steps in particular. Some final thoughts, just given the work that's been done over the past year and a half or so. There's definitely solutions that exist to mitigate risks in major events, but they are pricey. They're expensive and will require significant local investment. As well as other partner investments as well. Local drainage system benefits, as we talked about on the prior slide, may actually increase the total project benefits and help open the door to additional funding opportunities. It's a little bit beyond the scope of what we were doing in this project, but it is something that we've been able to identify as a recommendation going forward to try to be able to access higher benefits against the costs. And in regards to the improvements, there's still significant residual risk that's going to remain, particularly in the Dickinson Bayou watershed. So elevating structures, buyouts are going to have to be part of a comprehensive, holistic solution, because there's just some structures that are low enough that no matter what we do, we're not going to be able to remove that residual risk from those structures. Next slide, Brian. So some instructions for follow-up questions and comments are on the next slide. So as we mentioned, this is not the end of what we're trying to do here. We definitely would like to get your feedback. But I don't know if you've clicked it to go up with the next slide or not, but there you go. Please feel free to email the team. So our email address for the study is lccbb@leaguecity.com. Or you can also fill out the online form on the study website. and that's at www.leaguecity.com/LCCDB. So with that, I think we will turn it over and we'll have some time to try to address questions that have come up in tonight's meeting that we haven't already had a chance to address in the Q&A. Rachel?
Yep. Thank you, Brian and Chuck, and thank you to the project team. This concludes the presentation portion of tonight's meeting, and as we move into the Q&A, as I mentioned earlier, any questions or comments that were asked earlier in the chat that were not addressed during the presentation have been cataloged in our queue. During this portion of the meeting, I will read the comments or questions as they were received, and the members of the project team and panelists will answer based on the nature of the question and subject. We encourage all comments and communication with the team this evening, and all comments and questions will be captured in the study documentation. So our first question in the queue that we have is regarding the presentation. Will a copy of the presentation be available to participants after this meeting?
Yes, that's an easy one. I'll answer that one. Yes. Yeah. Hard ones are going to go to Jim. Yeah, hard ones will go to Jim, but I'll take the easy question with yes on that one. Will be available.
And then the next question is, are you keeping current of planned structures in and along Dickinson Bayou and in the watershed, like housing developments, boathouse structures that add to flow obstructions and additional runoffs? And how are you accounting for those?
Yeah, so I think Jim can help us on how we've accounted for structures in the waterway, and then I can try to help us with some of the other questions on there.
Yeah, so any existing structures were definitely captured, and those are typically represented in the hydraulic model by adjusting the roughness parameters in the model. So in areas where we have either a lot of structures or a lot of other obstructions, vegetation, otherwise we have higher Manning's and roughness values. In areas of just mowed grass, we have lower values. We also have been keeping abreast of some of the planned developments that are happening in the watershed, and so as that information has come into the study team, we've looked at maybe where we can pair some of these proposed detention basins with some of that development, or at least maybe not propose to put a detention basin where we know a development is occurring. So we've accounted for those types of projects in that way as part of the study.
Yeah, Jim, another thing that this project will allow all the cities in the county to evaluate development is, we have a comprehensive hydraulic model of Dickinson Bayou based on the new LIDAR and Atlas 14 data that did not exist previous to the study. The old model for Dickinson Bayou was, I think, decades old. And so as future improvements are considered, the impact of those improvements can be evaluated with the model in a more holistic way than they would have otherwise been. Generally, development is kind of evaluated on a localized impact level. The model, which will be provided to the stakeholders, is something that can be used to evaluate those things on a more holistic basis.
Yeah, that's right. We certainly hope that these models will be useful to all the stakeholders to help plan and design development in the watershed. So
Hey, Brian and Jim.
Best available data.
Brian and Jim, John Baumgartner speaking. Didn't the analysis look at both the current state and the ultimate state within the watershed based on land development patterns?
That's right. So we did look at the change in land use conditions. What we really can't foresee is kind of exact, structures. So we can't necessarily predict future structures, but we can predict, future land use patterns, whether that's going to be commercial or residential. That it's kind of at that level.
Right. And then the land use patterns generate how much runoff, assuming detention or no detention, is what I understood.
Correct.
That's correct.
Yeah, but so John, that's a great question. Our analysis, as we talked about earlier, was our future conditions assumes no detention provided for future development. So it is a worst case condition, because there's no way for us to determine exactly how much attention is going to be provided in each development, or where it'll be located, or how it'll be sized. So if development is constructed with detention requirements, what we presented as a worst case future condition should not happen, right? But even though we also have an existing conditions analysis, right, which is what it is like today, that could be used to understand downstream impact potential from future development as well.
And then the other question I think that was asked was, why can't you create a moratorium? And, as much as I'd like to have a moratorium for entire Galveston County, I don't think anybody's empowered me to do that. But I think that what we can do is share the comments with all the regulatory agents up and down the watershed, and they'll make their own decisions based on what they think is best for their individual agency.
And there has been general movement towards more stringent standards for development based on slab elevations and detention requirements on site.
Yeah.
Obviously, since Harvey, so I think they're trending in the right direction on those.
Yeah. Yeah, I mean, I can speak specifically for League City, and League City uses Atlas 14, and they require, detention for the 100-year event with 2 feet of freeboard, and they model the new development for the 500-year event, and, it has to show that it's above the 500-year event. But that's just the League City requirement. Galveston County, Dickinson, Santa Fe, the drainage districts, they all establish their own criteria. But they're all participating in this, and so obviously they see the question, and we'll share that with them.
It is an important conclusion in the study, right? Those requirements are important to the future development of the watershed.
Yeah, was that everything in that question? I think it was.
I think y'all covered everything. The next question is regarding developments in Galveston County and unincorporated areas of the Dickinson Bayou watershed, and cities regarding permitting are permitted based on 100-year flood data. Example is a planned 360-unit development near Cemetery Road. The question is, shouldn't there be a preliminary recommendation to utilize the 500-year data?
Yeah, so I think that gets to John's comment from the last one. So each individual jurisdiction is going, they have their own authority and their own recommendations on this thing. So we can't directly address that. What we can provide and what we are providing through this study is, the best available modeling of what those impacts are along the channel using the Atlas 14 data as well as the 100 and 500 year. I think this goes back to Hank Doogie's question as well, that what is the future condition that we're looking at as far as damages and stuff, and that the data that's coming out of the study is going to be able to show, if you build at this elevation, what your relative risk requirement is. And I think that's guidance that the jurisdictions can use to make their decisions as far as how they go forward on development.
Yeah, and I think as we look at future development, hopefully we develop it from the perspective the future development's not going to be impacted. Obviously, if there's increases in runoff, we don't manage that appropriately. There's some existing development impacts, which again, that's what we try to prevent with detention. But if we, require houses to be, 2 feet above the 100-year floodplain and 3 or 4 inches above the 500-year floodplain fully developed, there should be limited damages to the new development.
Yeah, it's a good point. A couple, maybe just statements to clarify kind of what we presented tonight and how it compared to previous data. So we were presenting Atlas 14 rainfall data, which the 100-year Atlas 14 rainfall data is pretty similar to the existing 500-year rainfall data. So cities that have adopted a 100-year Atlas 14 standard, it essentially would be the same as a 500-year standard from previous. So we saw a lot of cities before Atlas 14 got adopted fully saying, hey, let's use the 500 and put it 2 feet above that. So as cities adopt the Atlas 14, we can probably see things going down to the 100. Not necessarily, that's a bad thing. It's just better data. Also, Hurricane Harvey, look at the intensity for Harvey on a 24-hour basis. It was not an Atlas 14 500-year storm. So it's about 125-year intensity on a 24-hour basis. which is, again, a very strong storm. But when we showed tonight the 500-year event, that is an event that's larger than Harvey. So a massive storm event. And not saying it couldn't happen, but we just need to understand that Harvey wasn't that big.
Rachel?
Got it. Yeah, I think we have just one more question that really hasn't been answered. Would the PowerPoint be available? And this has already been answered, and yes. And someone asking if they can have it emailed to them, and yes, that PowerPoint will be emailed. I believe all the questions that we have here have been answered. But if anyone has anything else.
Yeah, I did see one. It was answered. I just wanted to call attention to it about dredging. That's something that comes up quite a bit, both on Clear Creek and Dickinson Bayou. Deepening the channel can have benefits, but as Jim Keith noted in his response, when we start seeing sea level impacts, deepening the channel doesn't necessarily allow us to convey any more water. So when we're upstream of where we have sea level impacts causing backwater, deepening the channel can increase conveyance. Once we start getting in a situation where we have sea level impacts, which in this case is kind of once you get east I-45, deepening the channel with dredging sometimes has pretty limited benefits and often would result in additional sedimentation shortly after you dredged it.
Yeah.
Okay, I do see two more questions that have come up. Did you consider the 10-year storm as a possible frequency for sizing facilities? And what would the incident cost be of the structure?
That's a good question. Go ahead, Jim.
You want me to take that one? Yeah, I'm starting to type a response. We considered the full range of storm frequencies as we looked at these mitigation alternatives, and I included the 10-year. Again, the focus of our study and the mitigation improvements was really to provide some relief for these larger, 100-year and 500-year storm events. So as you can see, even for those events, the cost per structure is still significant. But we did look, especially in the bowl area at the 10-year event, we still had significant flooding, and we looked at a lot of ways to try and get as much of that water out, even for a 10-year event, as we could.
Yeah, I mean, you make an argument that a 10-year, the conveyance improvements provide a lot of benefit, right? Move a lot of structures, but there's still a lot of need in the 10-year storm that even these structures can't provide because just where they're located in the floodplain. And some other structural improvements or non-structural improvements would be necessary.
We do have a comment sort of on the tail end of that, Brian, and saying that a uniform permitting strategy is necessary.
And that's something that, if there was a watershed improvement district or a Dickinson Bayou flood protection district established, it would potentially have some of those powers within the watershed assigned to it. There's another question in here about future condition flows. A good point is made that these entities are going to require, and there's no rise, no increase from future development. So why are we including a factor for additional flows? I think they do require no rise, but they typically based on some sort of maximum magnitude event, and they're usually mitigated with detention. And as we all know, detention at some point gets full, particularly residential detention ponds or commercial detention ponds take a long time to drain. And once full, the change in ground surface use from a field to concrete, even if it has a detention pond next to it, when it's full, it acts essentially like all concrete. And so we're going to experience additional runoff. So that's why we wanted to look at that in that way. Do you have anything to add on that?
No, I think that was a good answer. As we noted, it's conservative.
I did not see any additional questions in the chat. If anyone has any more comments, please put them in. If not, you can always email the project team, or you can go to the project website that we mentioned earlier. But if there are no additional questions or comments, On behalf of the LCCDB study team and the panelists, I would like to thank all the attendees who took time to participate and listen in this evening. You may email again, I'll put that out there, the project team at lccdb@leapcity.com anytime, and please visit the study website at leapcity.com/LCCDB for more information about the study and a copy of tonight's presentation and a video recording as it is made available. As there are no further comments or questions, we have reached the end of our Q&A portion, and the meeting is now concluded. Thank you all very much.
Appreciate everybody attending. Thank you.